Hi guys, welcome back to my YouTube channel, and let's get started with the next question of today's top 150 interview questions of LeetCode. So the today's question is Jump Game 2. In the last video, I have discussed the first version of this Jump Game 2, in which we have to return the possibility that whether we can reach till the end or not. Whereas in this question, the only major difference is that we have to return the minimum number of jumps to reach nums of n minus 1. And the test cases are generated such that you can always reach nums of n minus 1, that is, we will always reach the end. So let's get started with the discussion of the question. So in the previous question, as we know that we have to basically check that whether we can reach the end or not. So in that case also same sort of calculations happen, that we have to find the maximum, and if my max index outreaches my last index, or it is greater than or equal to my last index, I will simply return true. That's what the thing is. But in this case we have to return the minimum number of steps in which we can reach the last. So one thing as of common sense, how we will reach to the last and minimum steps. How we will reach? By taking the bigger jumps in the array, right? It means what we have to do, we have to find out the pattern of numbers in such a way that in the way when we take the jump, I reach my maximum index, I reach my last index, right? So let's compute a happy path which will actually reach the last index over here. So let me assume that I take only one step from 2 to 3, and I take 3 steps from the index, and I reach my last. Okay, fair enough. So what we are trying to do, we are trying to check each and every possibility for the number of jumps that we can take which is present at one index, right? So I think we can represent this scenario in some sort of searching algorithm, as I have done in this visual. Okay, so the ones in the pink color represents my indices, and the ones which I have written on my arrows represents the number of jumps that I can take. Okay, so when I am at 0th index, I have, so the maximum jumps that I can take from 0th index is 2. So it means I can either take 1 jump or I can take 2 jump, right? Fair enough. So suppose I take 1 jump when I only take 1 jump when I have to move from 0 to some other index. So if I take only 1 jump, I move to index number 1. Okay, so my index is also constantly updating and my jumps are also constantly updating. Okay, so I took 1 jump and I have reached index 1. So let's check the value which is present at index 1. It is 3. So it means how many jumps we can take at max? It means we can take at max 3 jumps in order to reach the end. So it means we can either take 1 jump, 2 jumps, or 3 jumps. Okay, so suppose I try to take only 1 jump while I'm at index 3. So what will happen? I will reach my index number 2, right? I'll reach over here. Good. And now let's check for index 2. How many jumps at max we can take? We can only take 1 jump. So I will move to index 3. Good. Represented. And how many steps can I take when I'm at index 3? I can take only 1. I'll reach my index 4. And yeah. So I have reached the end till using this method in 4 steps. Okay, so suppose I prefer to take 2 steps while I'm at 3. So I've reached here. And how many steps can I take from index 3? I can take only one step. It is to reach the end. So from the previous one, it's better that I have reduced one step and I can jump in 3 steps. Okay, so fine. So now let me assume that I take maximum of 3 jumps at this point. So where I will reach? I'll reach my last index. So I have done this task in 2 steps. Okay. Now suppose I think of taking 2 jumps while I am at index 2. Okay. So I've reached index number 2, and from index 2 how many jumps can we take at a time? We can only take max 1 jump. I've reached index 3, and from index 3 to index 4 how many jumps I can take at max? I can take at max 1 jump, because the value that is present at index 3 is 1. Okay, so I've reached my end. So using this path I have reached my end in 3 steps. So the minimum steps in which we can reach our path, in which we can reach the end, is 2. Okay. So what I have done in this, I have computed for each and every possibility. So when we have to compute for each and every possibility, what I will do? I will write a simple recursive function, and I will say that I have computed all my possibilities. So for recursion, what would be my time complexity? It would be something like order of n raised to power n, and the space complexity would be order of n, because I'm using an auxiliary stack space, right? So recursive solutions are not at all good, because they will be happening in O of in exponential time. So what I will try to do, I will simply try to memorize this solution, memorize, or I will try to use something like dynamic programming. So while using dynamic programming, since I know I'm changing 2 variables at a time. So what would be my time complexity in that case? It would be O of n square, and space complexity would also be O of n square, because I have to store my results in some other matrix where I can keep a track of changes of my index as well as the number of jumps that I will take at one point. Okay, fair enough. So using all of these concepts, we can at max achieve a solution in O of n square time. So, but the interviewer will not be happy. What he will demand from you? So let me write it down. He will demand something like O of n time and O of n space. So how to achieve it? Simply, we can approach this question greedily. So let's discuss. So now let's discuss the optimal solution for the problem. So let's analyze what we have to find out. We have to find out the minimum number of jumps in which we can reach the last point, last value, right? So to reach the last value in minimum jumps, what we have to find out? We have to find the maximum values amongst the array, so that we can reach the last, right? Because what is the benefit of taking the maximum values? Because maximum values will allow us to jump to much wide, like maximum values will basically cover the maximum coverage in the array. It means we are actually escaping maximum values in between the values which are preventing us to reach the end. So that's why what we will do. So initially we are at position 0, right? And now we have to move to last index. Like whenever we reach the last index, it means we have already got our answer. So from index 0, what is the minimum, at what all possibilities can we move? Yeah, So it means we can either move to 3 or we can either move to 1. So I'm marking this portion that when I am at 2, I can either move to 3, either move to 1. So it means I have got this segment of array where I can actually move when I am at 2. So in order to move to this segment, what are the minimum steps that I will actually take? It's 1, so I'll simply add 1. Okay, fair enough. So now what I will do, I will, since I've already computed all the possibilities for 2, right? It is 0 and 1 and 2, so fair enough. So now let's compute for the possibilities of possible steps that are there in this range which I have marked in green. So, and one more thing, what possibilities I need to compute? I need to compute all those possibilities which are not present in this green range. So what it could be? It could be either we can reach this index or we can reach the final index, right? So these are the two possibilities, these are the two possible answers that I can reach, which are not present in this green portion and which are the valid answers for 3. And amongst both of these answers, there is one answer which is actually helping us to reach the end. So the maximum index that I can reach with the help of 3 is 4. So the max index where I can reach with the help of 3 is 4. Okay, so I have already got one answer. So talking about the answer, like this possibility, I'm not including it because I already have this possibility as my answer. Like I already have an answer for this. So no need to recalculate it. Just leave it. Okay. So now let's move to the next range. That is the range which I have marked in the pink. So what all possible values can help? So what is the possible value at this point which can help me to reach the last? Only one possible way, right? And one more thing, before moving to this range, so these are all the values that are beyond my range, that are beyond my green range. So it means I have jumped from green to pink. So it means I took a near of one step to move again in this. So 1 plus 1 becomes 2. So the maximum answer that I have is 2. Okay, great. So let's move to the code of this problem. So let's get started. So whenever suppose there is one edge case which I forgot to discuss. So suppose I have only one element in my array. So what is the maximum jumps that I have to take in this case? That is 0. It means we have already reached the destination, that is the nth n minus 1th index, right? So let's discuss the code. So I took 3 variables left and right in order to compute my range, and jumps in order to calculate the number of jumps that I can take. So I took one while loop where it checks that whether my right portion, whether my right is less than the destination or not. And I took a variable farthest. Farthest basically determines the maximum stretch till where I can actually go from a nums of I. From a given nums of I, what is the maximum index that I can reach? So that's what I have been computing within this while loop. Fair enough. So within this while loop I have been computing this thing, that the farthest point that I can reach And when I compute the farthest point within a range, suppose since in this, like in this green range, I've already computed the farthest point, which is 4, the maximum index, which is 4. So then what I will do, I'll simply update my ranges to left to right plus 1 and right to farthest. Okay, let's just dry run this code on the given example. Okay, since I am already standing at index number 2, so initially what is the scenario, that my left and right both are 0. My left is also 0 and my right is also 0. Okay, and now what is the, since I am already at 0, so according to the question, what would be my left and right, what would be the farthest in this case? So farthest in this case would have been 2. 0 plus 2 is equal to, okay, so the maximum amongst 0 and 2 is 2. So the farthest value where I can reach at this point is 2. Okay, so my left is over here, my right is also over here, and I have already got my farthest. It means that already I have got a value where I can reach at this point. So what I will do, I will simply update my left to right plus 1. I'll move my left to 3 and my right will move to farthest position. So I've got this range using these values. So it means using 2, I've already got my decisions that I can take with this code. So the work of 2 is already over and I took one jump to move to this range. So at this point, what is, so my left is equal to 1 and right is equal to 2. So I will again compute the farthest point. So the farthest point while I am at index left is 1 plus 3, that is 4. Okay, and when I reach right, so the farthest point that I can reach is 2 plus 1, that is 3. And is 3 greater than 4? No. So the farthest point till now I have got is 4. Okay, fair enough. So now let's compute for, so now let's update our left and right. So my left has got updated to right plus 1, which is 2 plus 1 equal to 3, and my right is got updated to farthest, that is 4. So I've got this range, I've got these left and right values. So now let's compute the so I took one more jump in this case, that is I took maximum of 2 jumps at this point. Fair enough. So now let's compute the farthest over here. Since I already have the maximum farthest value as 4, so what is present at 3, index number 3, it is 3 plus 1, which is equal to 4. Cool. So I've already got my farthest, and now compute for 6 plus what do we say, 6 plus 4, which is equal to 10. Since 10 is out of my boundary, so it will automatically be broken, right? So I will, since I have not implemented this case yet, but I can implement that that if my right is always, and if my right is less than n minus 1, I can implement this condition. Then I will not, then there is no need to compute the maximums again and again till here. Okay, and we are done with it. Although algorithmically we have to compute the farthest, that is 10, so 4 is less than 10, so I will update my left to right plus 1, which is n, and my right is updated to 10, and both of these values are not in my indices, so I will simply exit from my while loop and I will return the number of jumps that I have taken. Okay, so now let's analyze the time complexity for this solution. It is big O of n and the space complexity big O of 1. So I hope guys this solution would have helped you a lot. If it helped, then please do like and subscribe my channel, and please do share this video with your friends. And if you feel that I have missed out something, feel free to mention it in the comment section. And if you want to connect with me for topics other than the DS algo, you can connect with me on the following 3 platforms mentioned in the description of the video. Thank you guys, and keep watching my videos.